Hello there, Khalid Amalwani here. So this is the second video in the tutorial on how to use FreeRTOS. In this tutorial video here, we're going to talk about queues, which is an API available to provide communication between various tasks in FreeRTOS. So I guess let's get started. So here's a picture which demonstrates a bit how queues work. Now, queues are all developed through the FIFO system, which stands for first in, first out. So how this works here, let's say task A, we create a queue here. So as mentioned here, so a queue will allow task A and task B to communicate. In this case here, the specific queue is built to only hold a maximum of 5 integers. Okay. First of all, a function here is created known as x equal 10. A function call, as we will talk about in the Arduino code later today, sends the x value here to the first of the queue. And then when it sends another value here of 20 towards the second. Now recall that the tasks work independently in a real-time operating system. As such, that's why it's always important to create a longer queue than usually necessary, because one task could be faster than the other. And I will talk how will that cause issues, but you might already guess it, that if the queue is full, then you can't put any more data inside the queue. And it depends on how you set it up. Usually it will make the code stop until it's full, or you will just miss data. In this case here, after that, it is received. Now, when it is received, when task B calls it, which is another function call that we're going to see today, the values that were right prior to it will move forward. So every single value that's here will move forward to the second value. Okay, so that's a visual approach of how queues work. Now let's get started with the code. So in this case here, this is the code you've just seen that allows the two LEDs to light up independently at different frequencies. And now we want to start a few queues. First thing we're going to do is we actually need to include the queues library. Now, when you downloaded your FreeRTOS library, the header file for the queue was included, and it is simply queue.h. After that, we need to declare the global variable. Now remember that queue is used between the different tasks. In other words, it's used between other functions. So you need to make sure that when you declare your queue, it has to be global, or at least the queue name. The proper convention to do this is call the queue variable at the beginning and then initialize inside void setup. In this case here, to initialize a queue handle, we just type in queue handle _t. And as you can see, it changes color, so it is correct. And let's say we're going to call here just data queue. Usually you should pick a more descriptive name depending on what you're building. In this case here, let's just name it data queue. Now to initialize your queue here, so let's add some comment for legibility purposes. To initialize the data queue, or in this case, we're assigning the data queue. And what we do here is just go data queue, and we use a special function that is available inside the queue.h library. And that is called xQueueReceive. And it's a very simple function here where you first put the number. If you recall from the picture we saw earlier here, in this case here, they created a queue that can hold a maximum of 5 integers. In this case here, let's say you can hold 6 integers, just for difference here. And then you need to specify how big the box is. Just a quick info about data types here. Every data type takes an amount of space. So long takes a bigger space than int, which takes a bigger space than byte, which takes a bigger space than char. So we need to tell the queue here how much space you need to allocate, and that is simply using the function command known as size of, and let's say we want it to be a float. So in this case here, what we did is we just created a queue handle for 6 places that has a size of, it has pretty much 6 spaces for floats. Now we just created the queue, and that means we can use it. So let's go to our function here, and let's say we want a, let's create actually another, or let's create another task actually. So let's say here, let's create a void task message. And let's go void. Once again, you just include this as a pretty much a convention. You need to include the void pointer here. And what this will actually do is it will just take in the various queues that we will create here, or we will send, and use them. So we're going to just have a while one here. We do not need any setup for this, so there's nothing prior to while one. And let's say we want to send in data when it is completed. So let's say here, let's remove these serial commands here for all of them. So there's 2 more functions that you're going to see. Oh, and then let's not forget to actually create a new task here. So remember, as task create, name of the function, simple name for the debugger, keep the default 128, keep null as a default. Let's put it, actually let's put it, it's not the top priority. So the first 2 here will just make sure that these are called, and we'll just say that the message is not equally as important. So that means you could skip a message once in a while, but that is not a big deal. How we send messages, it's quite simple. We just use something known as xQueueSend. Okay, and what the first parameter is the queue name. So the queue name here is called data queue. And then this is important. You need to send the address. So use the ampersand or shift 7. And you need to send the address of the variable you're going to store. Now, in this case here, we don't have a variable. That means we need to create one. So let's say we send in, let's say, we send in an int here. We create an int here, and we say, or actually, let's create a bool, or yes, let's create a bool for demonstration purposes. And let's say the bool is complete, and then we can go equal a, we always set it to false at the beginning, and then we can say bool is complete is equal to true. Okay. Of course, we don't need bool here. Now, That means that what we're actually going to send our bool, so we need to edit this. Instead of having floats, we can say it's the size of a bool. And of course, we send the address of the variable, which is complete. And lastly, here we need to send in or not send in. You define a parameter for how much time it should wait if it's full. So if remember, if we look at our drawing again, if the queue handle here is full, so in this case here we have 6. So if there's a 6 variable at the last box here, then that means that we need pretty much a way to make sure that we can handle this. So the last parameter here is what it does. So you can either define a number, which number will be how much microseconds should it wait before it skips it. Or you can use something known as port max delay. And this is a predefined value, which allows you to just wait for the maximum amount of time. So basically, it waits till there is an opening. In many cases, you will just need port max delay. Now, keep in mind, and that's where, remember, that's always important to test as you go. If there's a certain small error in your code, and you have a port max delay in several places because of your xQueueSend, and your xQueueReceive does use it too. If you don't test frequently, then one of these could cause the delay or could cause your stop to stop running because it's still waiting. Because when you have your port max delay here, it only waits here. So that means that all of this will not keep going anymore. So at least in that task. So you have to make sure that you test as you go. So you know where exactly the error is. Because in many cases, let's say, for example, you forgot to actually receive it. So that means all you're doing is you're sending data, you're going xQueueSend, and you keep sending data, but you're not receiving it. So it will stop. And you can try this on your own as well. So just don't have a receive message and let it run, and you will see that the LED pin 1 here, which if you recall was the red LED, will just stop blinking. Okay. And then we need to do the same thing actually for this one here. Now, there's multiple ways we can approach this. We can say that, okay, how about we put them both on the same queue handle? That could be a strategy, but then recall that it actually sends the value. So if it's a bool, you can only send true or false. So if you want to differentiate between this or this other message, then bool will not be the most appropriate choice. So another way we could do this actually is just create another queue handle. So we're going to say here that this is, we'll go change the name of that one actually and say that this is LED1Q, or let's call it this way. And make sure that we update this accordingly. And we can call the second one here LED2Q and create it. And for the sake of practice here, let's just change the number and say 5, for example, and go size of. And actually, while we're at it, we can even say, we can just change it. Let's say we have an int. Okay. And then what we'll do here is we're going to go and send that data. So let's actually say that it's an int here, and we call it as well complete status. And let's say it's 0 because it is not complete yet. And then here we'll go int complete status is equal to 1. And once again, we do not need int at the beginning here. And then we need to send that data. So we go xQueueSend, and then of course the name of the handle, and then the address of the variable. And then how much time we should wait. Okay, so that looks good. Oh, actually, I did realize a small mistake here. This is typed incorrectly, so it's actually port underscore max delay. Just like that. Okay, and then, so here we have it. We have our queue handle set up. Now, let's talk about how to receive it. First of all, to receive anything here, we just go xQueueReceive. Now, the only thing was xQueueReceive. If you notice, xQueueSend it changes color, or xQueueReceive does not. So just keep that in mind. And let's say it's pretty much the same parameters actually, so it's nothing different. So we go LED1 queue, and then we need to send the address of where to change the value. So and that means here that we need actually the new addresses. So remember that the every task is its own scope, and so that means that I can use the same name here for both of these. You can choose to use the same name. If it's confusing to you, you can choose a different name for it. But I tend to choose the same name just to, it allows me to debug things easier. So I know exactly where it's coming from. And in this case here, it does not need to be initialized. And then same thing with int complete status. And then of course we have our LED1 queue. We send in the address of the value to change, as in this case here, LED has in bools. So let's do it, the is complete. And then how much time should you wait if in this case it's received? So that means how much time should you wait if the queue is empty? In this case here, if you look at this code carefully, it will be empty in a lot of times because we have a vtask delay here, okay? Because we have a vtask delay here, it will wait 200 microseconds before, or at least 400 microseconds in the first one, and 1,000 or 1,200 microseconds in the second one before it updates the queue. So if you do actually put port max delay here, nothing will happen. So there's two ways to get at this, to to do this. The first one is we use an if statement here. And the if statement, we just check it with a predefined value here called PD pass. What this does is if whatever it received is an okay value, so it was changed, so it's complete was changed, then you're free to go ahead. You're free to complete the if statement. If what is received was incorrect, so it's either it wasn't a bool or it's empty, then it will not complete it. So in this case, we will not keep going. So in this case here, let's say that if it is complete, we can just put a 0 message that says LED1 complete. And then we can notice that because we have the xQueueReceive here, the bool function did change. And actually for the sake of practice here, and just so you can see that the variables are received, we can actually go like this. And change this way. Seems to be a slight mistake here. Okay. And so double checking the brackets here. So this one goes to this one. Perfect. Okay. So that looks good. So we have if is complete. So if is complete is true, then we'll run this. And then we can do pretty much the same thing as this one here for the second LED, but recall that it's an integer. And so we need to update this to complete status. And when we wait forever equals dd pass, and then if the complete status this is equal to 1. And then we can say here the LED2 is complete. So far that looks good. Now let's verify it. So there seems to be an issue with that one here. And that's probably because I did not declare it at the top. And then we can verify again. Okay, so that looks good. Let's go tools here, make sure the port is correct, and I do have an Arduino Uno connected. And then let's go and launch it. Now, while we're at it here, we can actually go and add, or actually let's keep it that way. I was thinking of adding an else statement showing that it is incomplete. But it is not really necessary because we're just showing how the xQueueReceive and send work. And it is uploaded. If we open this here, we will see that, so there is a slight mistake here. It only says the LED1 is complete and it never reaches LED2. And I want you to take a look at the code here and determine what the mistake is. It's actually quite simple. And you can feel free to pause the video. So the error here is that instead of saying LED1 here, it says LED2. So make sure that you always type everything correctly or you won't have, of course, the proper code. As you can see here, this wasn't a syntax error, so it wasn't able to pick up the mistake. And if I upload the code here, and open the serial monitor, you will see there's a slight lag. Okay, so that slight lag you see here is what is happening. It is waiting for, due to the port max delay in the xQueueReceive of LD1 queue here, it is waiting until the value is full. And as you remember here, the queue is only populated once every a fair bit of time because of the delay here, so it has to wait for that. So there's multiple ways to work at this. Now, a way that you might think off the top of your mind is like, okay, let's not wait around, put 0. Let's try that and see what happens. So as you can see here, nothing is happening. You can't see anything. So when you put 0 here, what you're trying to tell the code here is wait 0 seconds. So pretty much skip it. That's what 0 means, because you're saying don't wait at all for it. So that means it will never happen. So you need at least a value. Now I usually recommend about 10. 10 microseconds is not too big of a number. So we can just go ahead and upload it. And we can see here it's a bit quicker now, and you can see that you might start to see a bit of the different task delay. So you can see 2 and then 3 ones and 2s and as such. So that's the first way. Now, if we keep back to port max delay, another way you can do this is actually fill the queue more than once. You can actually repeat this more than once, and that fills the queue. So you're pretty much filling more boxes. Each time you call the xQueueSend to the queue here, a xQueueSend to the queue, you're filling it with one more box. So I said that this one has 6, so we can add about 3 and we'll be safe here, and even by 3 here. So if I upload this code here, oh, yep, so that is incorrect. Here we go. So it's a tiny bit quicker. There's still a little bit of lag because the task message is a bit quicker at taking the data than this here. So that is fine, and it's but so you might have to play around and see what is the best way to do this. And remember, your code could be doing different things. You might not be using task delay, so this will not be an issue. But keep that in mind that if you have a port max delay, it could make your at least that task lag and wait, and it might cause errors, and you might not know where the error is. So just look for that. So that covers queues. Now there's a few things to mention here. There is two types of queues available as well. There's a semaphore queue, which I will not go into. I'll just give you the name. And there's the mutex. So the semaphore queue is, there's two types. You can have a binary semaphore, as the name implies, it's either a 1 or a 0. So, you can either store a 1 or a 0 basically. And you can use that as something like the bool queue that we created here. There's also an integer or a variate semaphore, which means that it can have more than one. So as a value, I mean, so you can have 1, 2, 3, 4, any integer or as you want. Mutex is built off the semaphore. It is a binary semaphore, but it's used differently. So semaphore is usually used to send data. Mutex is used in a way to as signal, as a flag. So I won't go into too many details about this, but it is important to know. Now, one more thing to mention here is I did mention that the 128 here is a default value, but there is a command that you can use to determine what will be a more appropriate value. Because recall that if you have a lot of tasks, this takes space. So this tells the memory how much memory space you need to allocate for that specific task. So that command here is as follow. Can just show it to you here. We can just go like this. So it is UX high watermark X. That is just a variable. Usually an int would work. But it is not an int. If you want to go more details, you can look it as it is. This is the proper convention, and this is the function you use. Task get stack high watermark null, and based on the value here, of course, if the task is working, that means you do not need to increase the number. You most likely need to decrease it. It's slightly difficult to use, but if you are running out of memory space, then definitely look into how to use that. Last thing to mention here is there are quite a lot of resources available online here. And there is this video here, Introduction to RTOS Part 1, and by DigiKey, you can look into it. He explains RTOS quite well. It is a 3-part video. There's also the document created here by Circuit Digest. So it goes quite extensively through how RTOS works, queues, and it's a pretty good tutorial. I've used the tutorial quite significantly to develop this video. So it's a pretty good tutorial, has a lot of information, and this is also 3 parts. So So definitely look into how RTOS work. It is a pretty cool future to understand. RTOS is used for real life applications. So if you want to develop any further microcontroller applications, you definitely have to look into RTOS and how to use it. Anyways, I hope this was useful to you, and see you in the next video where I'll be explaining how the circle parkour RTOS code that I developed works, and I'll walk you through it. Have a great day, and good luck on your Arduino coding adventures.